Here we are on M5-91, so this is just going to be a bunch of cylinder volume problems just to make sure that we really understood what we did on the last page. So number 2 says, a circular swimming pool has a diameter of 30 feet and a height of 5 feet. What's the volume? So I always like drawing a picture for these. So here's our swimming pool. Now it says that there's a diameter of 30, the height of 5. So don't just go start plugging those numbers into the formula because we have the wrong numbers. We don't want 30, we don't want diameter, we want radius. So if the diameter is 30, the radius is 15. Now we can use these numbers. So if you remember from the last page, the volume formula was the volume of the area of the circle, so pi r squared times the height. So in this case, it'll be 15 squared times 5. Alright, so let's use our calculator. 15 squared is 225 times 5 is 1,125. So that times pi is 3,534.29-ish. So we need to put units on this. It was feet, and this is going to be cubed because this is a three-dimensional shape. Number 3, how many milliliters of liquid are needed to fill a cylindrical can with a radius of 3 centimeters and a height of 4.2? So again, you don't have to draw a picture, just sometimes it helps you visualize what it is you're working with. So in this case, they do give us the radius, so that's 3. The height is 4.2. Same formula. So we're taking the area of the circle times the height. 3 squared is 9. 9 times 4.2 equals 37.8. So that times pi is 118.75-ish. You can always round to about 2 decimal places. And in this case, the units are centimeters. So this will be centimeters cubed. Many newspapers are made of 100% wood. The wood used to make this paper can come from pine trees, which are typically about 60 feet tall and have diameters about 1 foot. However, only about half of the volume of each tree is turned into paper. Suppose it takes about 0.5 cubic inch of wood to make 1 sheet of paper. About how many sheets can be made from a typical pine tree? Show your work, blah, blah, blah. So basically what we need to start with is finding the volume of the tree, taking half of that, and then using that to find out how many pieces of paper we can make. So if I wanted the volume, in this case, we have a diameter of 1 foot, so we'll do half for the radius. So 0.5 squared times the height, which is 60. So all those multiplied together is 47.12 feet cubed. So that's the volume of the tree, but they're telling us that actually only half of it is turned into paper. So only half of this will actually become paper. So we're working with a volume of about 23.56 that we actually get to work with. Now, they're being really annoying and making us work in inches when we just calculated it in feet. Now, there's a couple of things we could have done. We could have actually converted it back here and used 6 instead of 0.5 because, 6 inches is half a foot, or we can convert it now. So you may not remember how to convert. If I want feet to inches, 1 foot is 12 inches. But I can't do that once because we don't have a singular foot. We have feet in 3 dimensions, so we actually need to multiply it 3 times. So basically what I need to do is take our volume and multiply it by 12 to the 3rd power. And I'm getting 4711.68, and that'll be inches cubed. So there's the volume in inches. So now, if it takes 0.5 cubic inches of wood to make a sheet of paper, if we take this and divide it by 0.5, that's going to be how many sheets of paper we can have. So that 40,000 divided by 0.5, and I'm getting 81,423 0.36, but we're talking about sheets of paper. So obviously you went around to a whole. So that's that many sheets of paper. So basically 81,000 sheets of paper from a single log of wood. So that's a good amount. All right. On number 5, they just look like simple volume problems, but you'll notice that they have something missing in each of them. So they're just kind of trying to see if you really understand the formula well enough to work with unknowns. So we're still going to put anything we know into the formula. So our formula still is volume is the area of the circle, so pi radius squared times the height. So we're just going to put what we know into it, and then we'll leave it there. So on A, we have this long cylindrical shape. We have a height of 13 and an unknown radius. So if I put what I know into the formula, pi is still pi. Okay, I don't know the radius, we'll leave that alone. And the height is 13. So it kind of is just showing like, okay, we don't know this right now, but it kind of helps us know if I found the radius, I can plug it in there, or even if I found the volume, I could put that in here and solve for the radius. On B, this is just a rectangular solid. So what you have is you want the area of the base times the height. In this case, the base is a rectangle. So maybe I want to define, like this bottom right here as the base, and that's a 4.5 by 3. So in which case it's actually length times width times height. So maybe I define the length as 4.5, the width as 3, and we don't know the height. So this is going to be whatever 4.5 times 3 is times height. And we could even simplify that. 4.5 times 3 is 13.5 height. C is just kind of like a squat cylinder with an unknown diameter. So if you remember, we don't want diameter though, we want radius. So for that radius, it'll be half of the diameter. So for our volume equation, pi, our radius d over 2 squared times our height, which is 5. And that's really most of what we could do. Maybe we could multiply pi times 5. I don't know if that would actually make it look more simple, but we can't really do much with diameter over 2 because it's just unknown.